functions in Swift. The first ask should be, why do we need functions in the first place? Try and think of a scenario that you're writing a piece of code that actually makes network calls. Maybe you're talking to a REST server, trying to make API calls, and you have some common functionality that you need to repeat in each of these service calls. It could be that you open up a HTTPS connection and then you perform a CERT exchange to validate that it's actually the right server you're talking to. It could be injecting some common headers in each and every request. And your app, as it grows, can go from 10 service calls to hundreds or thousands of service calls. And if you're just repeating the same code every place you have to make the service call, just too much code to write. So functions provide the capability of having reusable pieces of code that you can just tap on whenever you need it. Um, now, before we take a deep dive and start looking at what all the functions can do, let's try and have a look at the syntax. For some of the folks, syntax of functions in Swift looks different and seems weird than other programming languages, but I think it's more intuitive. So let's think of a scenario where you're writing a simple function to compute the area of a circle. So we will write down our problem statement, which is we want to compute the area of the circle. We know that the formula for doing so is pi into r square. So all good with that. Now, if I ask you to write a reusable function, which can just compute the area of a circle, how would you go about it? First is you need to write a function. Okay, so you write a piece of code that is a function. So that will start with some sort of a keyword to identify the function. And in Swift, it is func, which identifies function. Then once you have this some reusable piece of code, maybe it's 10 lines, maybe it's 20 lines, maybe it's 100 lines of code, there must be a way of reaching out and then calling that function, and so that you can actually get a result out of it. Just like you call other people, similarly, you need to give a name to the function so you can call it anywhere else, same as variables. So let's just call our function, okay, compute area of circle. And I do that. Okay, that's all I want to do for now. Okay, so now I know that, okay, I want to write a function which will compute area of a circle. All good. Now, as I go into the function and start thinking about the area that I'm supposed to compute, okay, I know that my first element, which is pi, okay, which is a variable, sorry, which is a constant, I'm just gonna know that, okay, it's coded to 3.14, so it's a constant. And then I need to compute the area, and the area is going to be pi into r square. Oh, I don't know the radius. And of course, if I'm writing a function, the radius is something that's going to be a variable, which is going to keep changing. So how should I get the radius? It means someone who is calling me must tell me the radius of the circle that I'm trying to compute the area for. And that's considered to be an argument. So we'll just go forward and say, okay, the argument will come and will be specified here, and it's going to be double. Okay, so now as you know, in Swift, actually the name of the function is split between the name of the function and the arguments. Is always set together. So the name of the function now becomes compute area of circle with radius, and you specify the radius as an argument. It's a double. Okay, so I know that, okay, with radius was the argument which was passed to us, which was a double, and I was going to go forward and square it. Okay, so that's going to give me my area of circle. And just for clarity, so that to say the r square is together, I put brackets around it. Okay, found. I computed the area of a circle. But what I'm supposed to do with that, should I just print it? Most cases, I will have to return this value back to the caller so the caller can use it, right? If someone came to me with a problem, and one of the students say that, okay, I have a problem to this question, they will give me some inputs about what the problem is. I will solve the problem for them, but then I need to tell them how I solved it or what the answer was. I shouldn't just solve it and forget about it, and then the student knows nothing about why or how I did something. So I need to tell the answer out. So that I will do with a written statement. And since now I've started thinking about in my method actually written something, I need to go forward and have my function return back something. And it's going to return a double back. Okay. So now as you started going over your logical process of thinking, it all makes sense in Swift. You first think that okay, you need to write a function, then you choose a name of the function, and as you are developing your function, you think about what are the arguments that are needed for your function to be effective, and eventually you think about what are the outputs the function can possibly return, and those are the outputs you actually go forward and list them. And in this case, it was a double. Now that's a function which has been written. This is not really going to work. Primary reason is that the exponent operator doesn't looks like carry raised power 2 in Swift. You do have a power function that you can use, but for now, I don't need to show and worry about other operations. This task is simple enough. I just want to do r square, so I can just take the radius, multiply it twice, and I have my pi r square handy. Now, again, this is just a reusable piece of code that has been written and is identified with the name and a function type. And we'll visit function types a bit later, so don't worry about it. But it has been identified with a function type with which you can invoke it. But there is no code being executed, nothing being published here because the function itself has not been asked to execute. To execute a function is simple. You will simply go forward and you will call the function and you'll pass it the arguments that you want it to pass, and that is pretty much it. And you call it, and now you have an answer which is available by r square 50.24. That's the answer, and that's how you will call functions later down the line. Now that was a bit of background, and we look at what all we can do with the functions shortly. As you can see, we have a bunch of topics to actually go through. But again, let's just revisit the signature once more because this is a bit important. You start with the func keyword to identify it's a function. You actually give it a name, and the function may or may not have any arguments, but it will always have a name. If there are no arguments, we'll see how it goes. But if there are arguments, the arguments are considered as part of the name. So unlike other programming languages where there's a function name and there are a comma delimited list of arguments, not in Swift, this function name is actually split across the name of argument. So the name of the function here is compute area of circle with radius. The argument is of type double and it returns a double back. And of course, we call it and we get the response back. Okay, all said and done. So let's go back and revisit some of the basics. By now you know that, okay, functions start with the func keyword, so that's what you will keep seeing. You also know that the functions must be called for them to get executed. And this is being demonstrated here again. If I go forward and run this, and I will configure this to run automatically, you see no, there's no output because it's not executed yet. I will have to go forward and call this function for this function to be executed. All good. And now, one thing also that you see is that there can be functions that do not accept any arguments. You still put a starting bracket and ending bracket to indicate that there are no arguments, but you still have that in the function syntax. And it will not have any return type, though it can have a return type. And we will visit the topic when we say that there is a written word which is possible in some time. But for now, simple functions, func keyword, name, and you just need to invoke it whenever you want the reusable piece of functionality to be called. Next, we start looking at passing arguments as we saw in our first example. Pretty straightforward. You use the func keyword, give it a name, and the arguments are part of the name of the function. So this is say hello to. Again, emphasis is that the argument labels are actually part of the function name. So this is say hello to, and it's of type string, so it takes the string value and goes forwards and prints it. Again, you have to actually call the function signature so as to execute a reusable piece of code, and then goes forwards and gets executed. Pretty straightforward. Moving on, now let's start looking at when there are multiple arguments which are present. Now, if there are multiple arguments which are present, you still separate them with comma, as in a lot of the programming languages. Still, the name of the function is the name of the function combined with the arguments. So you name of the function here is say hello to with greeting. So we are saying hello to someone with a greeting. So the two arguments, both are of type string in my case. When I invoke them, I have to say hello, and I go forward and pass on the parameters like Navdeep and how are you, and those are the values which will get printed. Another thing to note is that, as we said, the name of the functions are part. So as you see, when I try to do the autofill, say hello to with greeting, I can just press the enter and it will autofill for rest of the remaining stuff for me. So I can just stay again and say Tom, and then we can say how are you, Tom, and again the same piece of code will get executed the second time, and you get two outputs this time. So far, things should be pretty simple and straightforward. Now let's start looking at some more intricate stuff. Now, up till this point, most of the functionalities are present in other programming languages as well. What missing is that if you have worked on other programming language, you will see that there is too much method overloading which is being done. There will be a method like make service call, okay, and it will take a URL and will try hit the service. Then there will be second service call which will happening and saying that make service call uh, for application ID. And when you're writing this method, then what you're doing is that it will still hit a URL which is your passing, plus it will pass an application ID. Now, to reuse the code, your basic method, which was make service call with the URL, okay, would go forward and take the URL, but will hardcode some application ID and then call the other method. So the method loading overloading was being done because there was some utility or convenience functions that needed to be provided, which were not really doing anything but defaulting the values to something that was pre-known to the program. Now, Swift provides support for out-of-the-box default arguments, which is if the user does not specify the argument, I have a default value that I can use. So I don't really always need a value to be passed by the user. But if the user passes the value, I'm going to honor the value which is passed by the user. A value chosen by the user supersedes any value that has been defaulted, and I will use it. So in that manner, it prevents the need for writing a lot of functions and then overloading them with certain default values, as demonstrated here. Again, it's similar function to the one which you saw with multiple arguments. Say hello to with greeting. It's saying say hello to with greeting, and the catch here is that this time when I define with greeting, it's of type string, I go forward and define a initialization value. And I say that the default value is how is your day so far. Now, if the user calls say hello, and when the user types say hello, the user actually, the function is only one, as you know. But user sees two options. There is say hello to with greeting and say hello to. Just like in other programming languages, you had to code this functionality twice. You would end up doing something like um, with greeting, and probably it's better if I show in the multiple arguments one. And you will go forward and have a function which says say hello to, and in there you will go forward and hard code the greeting to how is your day so far. So you, you will go forward and end up having two different functions altogether. One which will be say hello to, and I will just for demonstration purposes comment this piece of code. And now you see that okay, it's saying first one is basically saying Navdeep, how are you? Because how are you was passed. Second one is Tom, and then it goes forward some default value. But I need to have two functions. But here I have one function, but when I try and use type the name, Xcode actually realizes that that's what I'm trying to do is to have two different functions with two different behaviors. One where the greeting is passed, one where the greeting is not passed, and gives me the choice of two functions to use. And I can use either one I really like. And I can go forward and say Tom if I want to. And if I do, then it's going to go forward and honor whatever option I have chosen. Like I've chosen the option of not having a defaults. So simply it's going to use how is your day so far, which was the default value. So in this way, again, Swift helped us prevent it takes extra work of just defining methods with some default values again and again out for us. A powerful feature of Swift. Next one is to remove argument labels altogether. Um, let's say for some reason or some place it really does not make sense to have an argument label. Now, personally, I think that using argument labels is more cleaner approach because you actually know what the argument really means. In other programming languages, you will end up with something like you call a function like make network service call, and then it will have string, int, and double. And you really don't know. You have to just click and read through the documentation to figure out what the first string is, what the second string is, what the int is, what the other int is, and what the double is. In Swift, it's actually have a label next to it. So I know that it's a greeting, and this one is whom I am addressing this message to. But if you really want to suppress the functionality, you can. And again, we go forward to an example of say hello to. And here what I did was I went forward and put an underscore in front of the two. And when I put the underscore in the front of two, it's the indicator to tell that, hey, just ignore the ignore the argument labels. So you don't really need to emphasize upon what the label is. And what it will result in that is when I call say hello, it still shows me that the value is a 2 because again it's a context. For context purposes the user still needs to know what that parameter of string really means. It's addressing to someone says 2, but it shows an underscore in front of it saying that I don't really need to specify the argument. So when I press this, see this time the 2 and string both are highlighted so that when I put a double quote it's going to auto remove the label, so I don't have to type the label. And you're not restricted to do so for all arguments that are being passed in the function. If you want to have some arguments have labels and some do not, that's perfectly valid. In the second example, that's exactly what we're doing. It is say hello to, and you can see that the first one we have to pass on the label as to, but for the second one we used underscore, so we don't need to worry about it. We need to pass any label and we simply passed how are you. Another option which you have in Swift is you can change the argument labels to something that you want the users to actually specify. I have used a much cumbersome option. Generally, it's the reverse case. So, for example, if I'm doing say hello, now you're seeing option which is saying that okay, to customer with name because that's the label which I specified, or I can choose to say and that you see that's a function and it actually shows at the bottom is that the full description for this to customer with name to and string. Sometimes it's done when you're trying to shorten, or sometimes it's done where you're trying to elaborate what that label means. Here, I thought that say hello to is not very elaborate. People can get confused on who is the to here. So I just went forward and elaborated, saying to customer with name. So it's very clear that okay, you are first greeting the customer, and then the value you're going to pass is the name of the customer. So I can actually go forward and change the labels which folks see. So people will actually, when they call my functions, they pass a particular label. But inside my function, I can define like a shorthand, and then I can use the shorthand inside my function all way long. Next one, return values. I touched upon it when I did the first example of function of computing the area of a circle. But here we revisit this again. What we are doing here is if we need a function to return a value back to the caller, And it doesn't necessarily need to be one of the existing data type. It can be a custom data type that you guys have defined, a class, a structure. It can be a closure statement, a tuple, if you want to return multiple values back to the caller. But it could be simple types like a string that I'm actually returning back here. And what you're saying is, again, say hello to with greeting function, but this time, instead of just printing the value, I'm actually returning the value back to the caller. So the caller can actually define a constant or a variable to accept the value that is being returned in by the function. And then I decided to simply go forward and print the value. I could have used a shorthand piece, which is I could have dumped the let piece altogether, could have gone forward and said that, okay, my print statement is directly calling this function because print requires a string and the function is returning a string, so it's going to get back the string and print is simply going to print the value. Next one is for the functions that do not return a value. And this is the first example which we saw, which was say hello, did not return a value. And as you can see, we just define the function, the name of the function, starting and closing brackets, and then write the piece of the code. I did not have to really specify that it's not returning anything. But internally for Swift, it's actually returning a value, but the return value is of type void. So if I write a function saying that function say hello again, and say that it actually returns something of type void, that is perfectly valid because that's how Swift is actually computing this to be. And then I go forward and define another function saying say hello without void. In reality, both the functions are doing the same thing. They are both uh, are functions that do not return a value. And in this example, I'm just executing both the functions and just showing that, okay, they both say hello. But let's start looking at type of. And when I say type of, just like variables and data types, I can do the type of for functions as well. And this time I want to know the type of say hello. Okay. And this say hello. Okay, I don't need the return. I'm not trying to execute it, so I don't need to pass on the method arguments. But I say, what's the type of say hello? And think this is not executing for, oh, sorry, this is executed. So as you can see, it is of type, it's basically the type of is what the return type, what the input values that is accepting is string. And what's it returning? You can see this arrow. It's basically returning back nothing, starting in the brackets void. And if I go forward and now check the type of the other function, which is say hello without void. Okay, let's do that. It's exactly the same type, even though one explicitly goes forward and returns something of type void, other does not. The function type is the same. And when I come talk about function types, I'm going to just jump over and visit the function types because I'm talking about the type here. The function types basically indicates is um, what are the arguments that are accepted by my function and what are the return values that the function returns. Now, looking at the say hello example again, it accepts an argument of type string and it returns a value of void. Say hello with void without void also accepts a string and returns nothing. So it's still returning void. The function types, as you can see in these two lines 20 and 21, are exactly the same. And what it means is that um, in Swift, this can be identified as the same closure block statements. Now, we have no visited closures, but we will visit them. Just keep in mind that when we visit them, then these function types are going to be very important. For now, whenever you're calling a function, you will call it by a name. And definitely you will pass it some arguments and there will be, they may or may not be a return value. Now, considering the example where we may or have a written value, and again in this example I have gone forward and defined a function saying say hello to with greeting, and greeting has a default value and it is returning something of type string, and that's the formatted message that is actually returning back. What happens when I call this function? Let's say I went forward and call this function. I call say hello to with greeting, all good. Inside it is the print statement. and everything looks good and dandy. There is no error, there is no warning. All good. But in real life applications, what's the recommended or a Swifty approach of handling this scenario is to be still more explicit. Now, if someone is reviewing your piece of code, then he's confused that you call a function which returned a value, but then you didn't do anything with the value. Was it intentional or you just made a coding mistake? So your reviewer may send your code back to you indicating, oh, did you do a mistake here? This function is supposed to return a string, but you are not really using it. Did you forget to use it? And you might have to go back and say that, well, yes, it returns a string just for the purposes that what string was finally formulated, but it also prints it, and I intended to just use the print function, so I'm really ignoring the value. You can make this explicit by just having the value which is being written by the say hello function assigned to an underscore, which is equivalent to saying that, okay, I understand that this function returns a value. I do not intend to use this value, so I'm going to intentionally ignore this value. Um, Now with this, that's all that you need to know about functions. Quick recap, the functions basically start with the func keyword. Then you will go forward and define a name of the reusable block of code. That's how you will invoke the function. You will go forward and define what all parameters you need as input to actually do something meaningful. Each parameter will be labeled, so there will be a label assigned to it. The function name is a combination of the function name and the labels together. So say hello to with greeting is the function name, which is present here. The function may or may not return a value. If it returns a value, you must specify with a forward arrow. If it does not, you can skip it, but it's equivalent to you saying that it is returning something of type void. The arguments itself, you can actually go forward and default someone, which will actually result in logical creation of multiple methods with method overloading with and without the arguments. And of course, you can go forward and change the labels which the user has to pass versus the labels that you actually use within your code. Uh, And if you are interested in checking or getting sample handle to the examples that I actually have used inside this tutorial, then just click on the link in the description of this video. It will take you to the GitHub site, which is the public GitHub, and you can download this sample playground to go forward and play with functions in Swift. Thank you. Bye bye.